All right, on number 72, we're trying to solve for x, and we've definitely got a bit of a problem. This stuff's tangled up in parentheses. If this was equal to 0, I would just set x equal to 0 and 5x plus 8 equal to 0, but it's equal to 4, so you've got to get rid of that 4. Basically what you're going to have to do is get rid of the parentheses. Let's see if I can zoom in on this a little bit. That might help a tiny bit. Alright, so to get rid of the parentheses, we'll send in the x to each term, and that'll give us 5x squared, okay, plus 8x, and that still equals 4, and now you want to get rid of the 4, because you want it equal to, you want this side of the equation to be 0. Alright, so subtract 4, where that 6 came from. Subtract 4 from this side, subtract 4 from this side, and you get 5x squared plus 8x minus 4. And if you have 4, take away 4, you get 0. And now you proceed down the list. GCF, no. 2 terms, no. 3 terms, yes. Something in front of x squared. Okay, so you multiply 5 times 4, that gives you 20, and list your factors. 1 times 20, 2 times 10, 3 won't work, 4 times 5, there's all your factors. And to get a difference of positive 8, it must be positive 10, negative 2. So the factored form of this trinomial is, whoops, I can't just plug it in right away, can I? Because I've got something in front of x squared. So all I've done here is figure out what goes in the box. Okay, I'll have to zoom out for this. And here's, I'll zoom out again. All right. So the first term goes in the first box. The last term goes in the last box. And these other two, that's why we did all the work here. So that's 4, oops, sorry. These are the two that worked, right? So it's negative 2 and positive 10. All right, let me change this out. So here's negative 2 and positive 10, and you have to remember to put an x in each one. Okay, factoring out your GCF, you get 2. Here you can just get a 1x. Here you can get a 5x, and coming across you can get a negative 2. Remember, if there's negative there, you pull it out. So the factored form of this is x plus 2 times 5x minus 2 equals 0. You have something times something is 0, so use the 0 factor property, and you'll set the first one equal to 0, so x plus 2 equals 0. Take your second one, 5x, sorry folks, 5x minus 2 equals 0, and then you solve each one for x. So here you would subtract 2 and subtract 2, x equals negative 2. Here you would add 2, and you have 5x equals 2. Get rid of your 5 and run off the screen. Alright, it's getting small now. So x equals 2/5. Alright, So well, I can't even fit it there. So your answer is x equals -2, comma 2/5. Okay, that's 72. That was pretty involved. We'll tackle 73 and 74, and again they are both pretty involved. In fact, I'm going to need another piece of paper. Alright. For 73, I guess I'll start out zoomed in a little bit. Okay. We've been using the zero factor property, and you have parentheses on each side, so this is pretty involved. You're going to have to get rid of your parentheses and then get everything on one side so it's equal to 0. Alright, so maybe to just show getting rid of the parentheses, we'll send in the 5 to each term, so that's 5x plus 5 over there. On this side, we'll send in the 5 to each term, so that's 5x squared plus 30. And then whatever was there, we'll have to bring down. So there's our equal sign, 35x. And this is a positive 5x squared. Notice I need a sign in between here, or else it looks like everything's supposed to be multiplied. And up here you had things being added or subtracted. Okay, so I'll put a plus sign here. Alright, now I want everything on one side and 0 on the other. So I'm going to, and instead of doing this in one step or 2 steps, I think I'll just do it in 1 step. I'm going to subtract 5 from each side, so that 5, the like term, is right here. Alright, and I'm also going to subtract 5x from each side. And this is my like term here, so minus 5x. Okay, usually I do just one thing at a time, but this one's pretty involved. And then I just draw a line and bring everything down. This turns into 0 equals, and then you have 30x, 5x squared, and this is plus 25 now. Okay, now we're going to have 2 considerations. I want this arranged in descending order, and most of you would probably prefer to have 0 on the right hand side, so I'll just rearrange all that at once, and I'm going to have to slide this up. Alright, so if I take everything from this side of the equal sign, I can put it over here, as long as I take everything on this side of the equal sign and put it over here. Okay, so that's exactly what I'm going to do. 5x squared is going to be first, and then the 30x, it's positive, and then plus 25, and then on the other side of the equal sign it's equals 0. Okay, now I'm going to slide that up. Again, I just took everything from this side and put it over here, everything from this side and put it over here. Alright, and now we have this to work with. Going down our list, once we're ready to try factoring, GCF, yes, so we'll factor it out of there. We can get a 5 out of each term. So if I factor a 5 out of each term, I'll be left with, got some blue on my hand there, it's still going to be equal to 0, whatever it is. This would be x squared plus 6x, and then plus 5. Okay, and we need to factor that. You grab your last term, list all the factors, 1 and 5, that's a short list. Fortunately it's a sum, so positive 1, positive 5 would give me a positive 6. So this can be factored as x plus 1, x plus 5, and this 5 comes down, and all this is equal to 0. Okay, so now to solve for x, you set your each factor has to get set equal to 0. So 5 equals 0 is kind of crazy. It's not equal, so you just toss that value. Okay, that doesn't make any sense. You grab your next one, x plus 1 equals 0, and then x plus 5 equals 0. You solve for x. Get rid of the 1. Get rid of the 5. And you have x equals negative 5 comma 1. Oops, that's negative 1, isn't it? Okay. So that takes care of number 73 and number 74. I'll get rid of that piece of paper. Alright. So number 74, we'll start out zooming in a little. I know I won't get to stay there, but alright. Again, you got x squareds, and we've been using the 0 factor property, so I'm going to get rid of the 6x squared and get rid of the 5x. So I'll show that. I'm going to just do 2 steps at once here because it's pretty involved. So I'm going to subtract 6x squared, and I'm going to add 5x to get rid of it. Okay, you always do the opposite operation. And if I put negative 6x squared on one side, I have to put it over here. There's my like term. So I'll put negative 6x squared right there. And if I put plus 5x on one side, I have to put plus 5x on the other. And then I just draw a line and bring everything down. Alright, so there's my line. Negative 3x squared, negative 6x squared. I have negative 9x squared, and these are both positive, so I have positive 12x, and that would be a 0, that would be a 0, so this equals 0. Okay, and now you proceed down the list. GCF, yes, well, factor it out. I don't really like negative in front here. Oh, you can't see the negative. Well, now you can. I don't really like a negative in front. There's no particular reason to factor it out other than normally I would. I'll go ahead and factor out negative 3x. I can get a 3 out of here and an x. I can get a 3 and an x out of there. If you just factor out a positive 3x from each term, you'll actually still end up with the same answers, strangely enough. But I'm going to factor out negative 3x. So if I factor negative 3x out of there, I'll be left with 3x. If I factor negative 3x out of there, I'll have a negative 4 equals 0. And now you have something times something equals 0. So I grab each one and set it equal to 0. So negative 3x equals 0. And 3x minus 4 equals 0. So to get rid of your negative 3, you divide by negative 3, divide by negative 3, and you get off the screen. So you get x equals 0, 0 divided by negative 3. And over here you would add 4 to each side. And you get 3x equals 4. And divide by 3, divide by 3. And you get x equals, falling off my screen here a little more, 4/3. So I get x equals 0 and 4/3. I'm a little uneasy about this. Alright, so let's put that. X equals 0, comma, 4/3. And I'll just experiment real quick and see, well, what would happen if instead of factoring out a negative 3x, I factored out a positive 3x. I would have had 3x. That would have been negative 3x plus 4. And this all was equal to 0. I'm going to slide this over just to show you how it worked out if I'd gone down a different road. Okay, so then I would say 3x equals 0. And I would say negative 3x plus 4 equals 0. And I would divide each side by 3. So I would get x equals 0. And notice what happens over here. If I, to get rid of the 4, subtract 4 from each side, so I'm left with negative 3x equals negative 4. I'm running out of room here. And now to get x by itself, I would divide by a negative 3, divide by negative 3. So I would get x equals negative divided by a negative, a positive 4/3. So I would still get x equals 0 and a positive 4/3. I know that might seem kind of strange. But it's basically because we did the algebra correctly. Alright, so you can either factor out a negative 3x or a positive 3x. You will get the same answer.